Welcome, Algebra 2 Trig. We are creating the Chapter 6 study guide video. Unfortunately, with the new document camera, we're doing it a little bit different. So you're actually seeing the screen of in class. So I'm here. Hi. So hopefully this works. I just couldn't figure it out, and so I figured better than nothing. Okay, so we're going to start on number 1. Number 1 says to find the reference angle. Remember, really important here with reference angles is that reference angles, when that says, like, find the reference angle, this is telling me, okay, my answer needs to be between 0 and 90 degrees. So it's an acute angle. So we're thinking about, okay, anything in between 0 and 90. Okay, so, and also, we're always going back to the x-axis. So that's really important. We're going back to the x-axis. So for 290, if I were to graph my coordinate plane, remember we have 0, 90, 180, and 270, and then back up to 360. So if I'm looking at 290, 290 is in quadrant 4, so it's at about here. So we've gone like this whole distance, looped around, and we've gone to 290. And so to find the reference angle, it's essentially saying, okay, take your end angle and go back to the x-axis. And so our closest x-axis is 360. So to find our reference angle, all we would have to do is do 360 minus 290, and we would get 70 degrees. Now, if there was, let's say it was in quadrant 3, and so it's here, well, the closest x-axis would be 180. So we'd subtract from 180. If it was in quadrant 2, well, the closest x-axis would be 180, so we'd subtract 180. If it's in quadrant 1, well, if it's in quadrant 1, it's already a reference angle. It's already between 0 and 90, so we don't have to do anything. Okay, so let's move on to number 2. Number 2 says to find the reference angle for negative 5 pi over 4. Now, if it's in radians, what's really nice about the radians is you don't have to do any math work here. All you have to do is see that 4 in the denominator, and 4 correlates to any reference angle or any like radian that has a reference angle of 45 degrees. And so all we would have to do is say, okay, 45 degrees. Let's say it was the denominator was 3. Well, if the denominator is 3, then all we would have to do is it would be 60 degrees. If the denominator was 6, all we would have to do is reference angle of 30. So 4 is 45, 6 is 30, and 3 is 60. Okay, so on to number 3. It says if sine theta is equal to negative rad 3 over 4, and pi is less than theta, which is less than 3 pi over 2, find the remaining trig functions. Okay, so first off, what this information is telling us is it's giving us essentially what quadrant my triangle is going to be in. And so if you remember our unit circle, so we have pi over 2, pi, 3 pi over 2, and 2 pi, I guess that's 0 also. So if my theta, or my angle measure, is between pi and 3 pi over 2, well then it's telling me it's in quadrant 3. Okay, so now at this point, what I typically do with these is I draw them actually like in that quadrant. And the reason why I draw in that quadrant is it helps me to remember the signs of the triangle, essentially, the S, I, G, and S. Okay, so we put it in quadrant 3. And remember, sine is equal to, so it's giving us, remember, sine is opposite over hypotenuse. So it's giving us our opposite is rad 3, and our hypotenuse is 4. Now remember, it's negative, so what's negative here? Well, the hypotenuse is always positive, and this is going down, and so it's a negative y, so it's a negative rad 3. And then once we get this side, well, it's a negative x value, so same thing, this is going to be negative, whatever we get there. So I'm just going to use the Pythagorean theorem here. So x squared plus negative rad 3 squared equals 4 squared. Well, when I square a negative, the negative goes away. And then when I square a square root, well, the square root goes away too. So I'm left with x squared plus 3 equals 16. Subtract 3 from both sides, and I get x squared equals 13. Square root both sides, x equals the square root of 13. So remember, it's negative square root 13 because it's the negative direction, because it's in quadrant 3. Okay, so now we have our opposite, our adjacent, and our hypotenuse, and we can start filling in for all of our other trig functions. So we already have sine, so we're going to find cosine, tangent, cosecant, secant, and cotangent. Okay, so remember cosine is adjacent over hypotenuse. So the adjacent is negative rad 13, the hypotenuse is 4, so negative rad 13 over 4, and that's that. For tangent, tangent is opposite over the adjacent. So I'm going to kind of do this one over here, is equal to, so it would be negative rad 3 over negative rad 13. And so remember, the first thing I would say is, okay, my negatives cancel, right? Negative over a negative is positive. But then we want to rationalize the denominator. So we're going to multiply the top by rad 13 and then the bottom also by rad 13. And so what happens is because both of these are inside a square root, we can actually multiply them together. And so rad 3 times rad 13 gets me rad 39, and then rad 13 times rad 13 becomes just regular 13. So tangent would be rad 39 over 13. Okay, and then cosecant. So remember, cosecant is the reciprocal of sine, so it's the hypotenuse over the opposite. So it would be 4 over negative rad 3. So if we rationalize the denominator, it would be negative 4 rad 3 over 3. Secant is the hypotenuse over the adjacent, and so that would be 4 over negative rad 13. We need to, again, rationalize the denominator, so it would be negative 4 rad 13 over 13. And then cotangent, cotangent is the adjacent over the opposite. And then, so to find that, it's really similar to tangent, obviously. But so it's going to be the adjacent, so negative rad 13, over the opposite, so negative rad 3. So first, of course, my negatives become positive, and then I need to rationalize the denominator. So I'm multiplying it by rad 3 over rad 3. Well, what happens is kind of the same thing that happened up here. They're both under square root, rad 13 times rad 3. They're like, we can just multiply them to become rad 39 over 3. And that's it for number 3. Okay, so for number 4, it says if secant is equal to negative 5/3 and cotangent is less than 0, find the remaining trig functions. So this is giving us some more information about the quadrant that it's in, and then we can use the information from secant to help us also. So first, it's telling us, okay, cotangent or tangent, doesn't matter, is going to be negative. And then secant or cosine, because the reciprocals are going to be the same sign. Cosine, well, this is negative, so cosine is negative. So then we think, okay, what quadrant is cosine negative and tangent negative? And that's actually going to be quadrant 2. Okay, so I'm again going to draw out my graph and then put a triangle in quadrant 2. Okay, so it gives us secant. So secant theta is equal to negative 5 over 3. And remember, secant is hypotenuse over adjacent. So the hypotenuse is 5, and the adjacent is 3. Now we need to check our signs. So this is going over a negative x direction. So the 3 is the negative. And that's how we got that, because the hypotenuse always positive. Okay, so then from there, we're going to use the quadratic formula. So negative 3 squared plus x squared equals 5 squared. So 25 minus 9 gets me 16. So x is equal to 4. I want to check the sign of 4 also, but because it's going up, positive y direction, this is going to stay positive, so it's fine. Okay, so now I'm just going to label everything. I have my opposite, my hypotenuse, and my adjacent. And so now I can find my sine, my cosine, tangent, cosecant, and cotangent. Okay, so sine is opposite over hypotenuse, so 4 over 5. No rationalizing denominators here. Woo, woo. Cosine is adjacent over hypotenuse, so negative 3 over 5, which makes sense because that's reciprocal of secant. So 5 over 3, we flip it to get negative 3 over 5. Tangent, opposite over adjacent, so negative 4/3. Cosecant is hypotenuse over opposite, or we could flip sign, same thing, 5 over 4. Cotangent is the reciprocal of tangent, or it's adjacent over opposite, so negative 3/4. And that does it for 4. So that one's nice and easy because there's no rationalizing the denominator there. Okay, so number 5 says name the quadrant theta is in if cosecant theta is less than 0 and tangent is less than 0. So remember, cosecant is the reciprocal of sine, so that's saying sine is negative. And then if tangent is less than 0, it's negative 2. So we have to think, okay, what quadrant is sine negative in and tangent negative in? And so that is in quadrant 4. So I guess I could have written it on my answer line. So quadrant 4. And that's something, I think it's easiest just to memorize that. And remember, like I showed you, you can also do this. All of them are positive. Sine is positive. Tangent is positive. And cosine is positive. So you can use that if you want to memorize that. That's fine too. Okay. So let's move on to number 6. 6 is using your trig identities. If you do not have these memorized, you need to have these memorized. You need to make flashcards. You need to do whatever you need to do, but you need to make sure that you have these memorized. Okay, so cosecant squared 28 minus 1. It says use your trig identities to find the exact value. So that's a hint. Use your trig identities. Okay, so first thing, remember my hints. So we are thinking, okay, there's only one angle measure, so I don't have to worry about getting them in the same angle measure. And your big hint should be this squared. That should be like a huge indicator to you that you should be looking at your Pythagorean identities. And so one of your Pythagorean identities is that cosecant squared theta is equal to 1 plus cotangent squared theta. And so what I would do from there is I would look here and see, okay, can I rearrange rearrange it. So I have cosecant squared theta minus 1. And I can, because I can subtract 1 from right here and move it over here. And so cosecant, oh, I forgot the theta, sorry. So cosecant squared theta minus 1 equals cotangent squared theta. So I just rearranged it. And so essentially what that's saying is it's almost like thinking about substitution in a sense. Like saying, okay, if I know that cosecant squared theta equals 1, well, this says cosecant squared 28 minus 1. And I know that that whole thing equals cotangent squared theta. So that means that this whole thing is going to equal cotangent squared 28. And that's my final answer. There's nothing really more you could do to simplify it. You could write it cosine squared 28 over sine squared 28, but that's totally unnecessary. So you're essentially saying, okay, cosecant squared 28 minus 1 is the same as cotangent squared 28 because of this identity. So knowing your identities is going to be really, really important. Okay, let's move on to number 7. So we have cotangent of 32 minus sine of 58 over sine of 32, blah, 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 blah. Okay, so your first thing that you're going to want to do is you always, like, first step, always, always, always you want to get the same angle measure. And so it doesn't matter which one you use, but I'm going to switch all of my 58s to 32. The reason why, I have 1, 2, 3 32s and 2 58s. So that's really the only thought process there. So cotangent 32 stays the same, but we're going to change sine of 58 and replace it with its complementary angles theorem. So remember, sine goes with cosine when we're doing our complementary angles theorem, and it's 90 minus 58. Sine of 32 is going to stay the same, plus, and tangent 32 is going to stay the same, but tangent 58, we're going to use our complementary angles theorem, so tangent goes to cotangent, and cotangent of 90 minus 58. Okay, so I'm just going to kind of rewrite that simplified. And really the whole goal of that is just we want to get it so we have the same angle measure throughout. And that's going to help us to simplify. Okay, so at this point, there's a few things you can do. I mean, we can always change all of my cotangents to cosine and sine and tangent to sine and cosine. So why don't we do that? So cotangent is cosine of 32 all over sine of 32. This is already in cosine and sine, so we don't have to do anything there. Plus, okay, tangent 32. I'm going to put this whole thing in parentheses just so we don't forget that we're multiplying it all together. Tangent is sine of 32 over cosine of 32 times cotangent, which is cosine of 32 over sine of 32. Okay, so at this point, hopefully you're seeing what's happening here. And so cosine of 32 over sine of 32 minus same exact thing. What happens is that goes away and becomes just 0. And then this, what happens here, well, sine of 32 and sine of 32 cancel. Cosine of 32 and cosine of 32 cancel. And when everything cancels out, it equals 1. Don't forget that. Some of you did. So 0 plus 1 is just 1. And so that would be my final answer. Okay, let's keep going. So we're on to number 8, tangent of 40 over cotangent of 50. So first thing, same thing, we want to get our angle measures to be the same. So it doesn't matter which one you change to. I'm just going to change 50. So cotangent, if I'm going to use the complementary angles theorem, cotangent goes with tangent. and 90 minus 50. So that gets me tangent 40 over tangent 40. Anything over itself equals 1. So another 1 there. Okay, and then we have cosine squared 70 minus 1 plus cosine squared 20. Okay, so at this point, what I would do is I would first rule of thumb, get the angle measures to be the same. So I'm going to first change that 20 degrees. I'm going to change that to 70. So I have cosine squared 70 minus 1 plus, if we're using the complementary angles theorem, it's going to be sine. So it would be sine squared 90 minus 20. And lucky us, it gets us sine squared 70. Now, I think on yours, on your work, what I did, what I posted online, and what I would do here is I recognize that, okay, we have cosine squared and sine squared. So I can actually rearrange it. All I'm going to do is just swap the order. I'm not changing the actual equation. Remember, with adding, you can change the order as long as you keep the sign. So cosine squared 70, I'm going to keep there. I'm going to move the plus sine squared 70 to be second. And then the minus 1 is going to come after. Well, hopefully you guys have this one down because this one is our Pythagorean identity, our main Pythagorean identity. So remember, cosine squared theta plus sine squared theta equals 1. So I have cosine squared 70 plus sine squared 70. They're the same angle measure, and so it's kind of the same thing as substitution here. I have cosine, I have this whole thing, whoops, and I know it's the same as 1, so then I can just use substitution, and I have 1 minus 1. And so 1 minus 1 is 0. Now, is that the only way to solve that problem? No, you can solve it a bunch of different ways, actually. That's just one way of solving it. You could have also recognized that cosine squared 70 minus 1, you could rearrange that, and you would actually get negative sine squared 70. And so you'd have negative sine squared 70 plus sine squared 70, which would cancel. There's just a bunch of different ways that you could really rearrange this. So, but that's just one of the ways. Okay, so let's continue on with number 10. Oh, there's 10. Okay, there it is. So we have 1 minus cosine squared 35 plus sine squared 55. So again, our first thing, always want to do first, is we want to get our same angle measures. I'm going to get them to be both 35. So sine squared is going to change. Remember, sine goes to cosine. So and 90 minus 55, thank goodness, works out to be 35. So now I have the same angle measure, and now I'm like, wait, I have a cosine squared and cosine squared, what's going on? Now, there's a few ways that you can look at this. You can look at it as, okay, well, what's negative cosine squared 35 plus cosine squared 35? Well, that's 0, right? Or, I recognized it, but that's not what I did on my work. So some of you guys might not see that because you forget that that negative is with that cosine and not with the 1. Another thing you could have done is you could have recognized, okay, this, so we have sine squared theta plus cosine squared theta equals 1. And so you could have recognized, okay, if I move the cosine squared theta over to this side, I have sine squared theta equals 1 minus, voila, cosine squared theta. And so again, I can use substitution, and I can say, okay, I know 1 minus cosine squared 75 or 35 is the same as sine squared 35. and bring down that cosine squared 35. And then now I have sine squared plus cosine squared, same angle, simplifies to be 1. So if you haven't picked up on it yet, you should recognize you really have to know your identities. If you don't know your identities, that is what you should be focusing on. That should be your main concern, is just knowing your identities frontwards and backwards. Okay, so let's move on to number 11. Number 11 says cosine 35 sine 55 plus sine 35 cosine 55. So, of course, first thing, we're going to get the same angle measure. I'm going to get them all to be 35. So cosine 35. So sine, if we're going to use the complementary angles theorem, we're going to change it to cosine. So cosine of 90 minus 55 plus sine 35. We're going to keep that guy the same. And then we're going to change cosine 55 to be sine using the complementary angles theorem. And then we can simplify. So I have cosine 35 times cosine 35 plus sine 35 times sine 35. Now, because these are the same, cosine 35 times cosine 35, what that essentially means is it's cosine squared 35. Just like if you had x times x, it becomes x squared. Cosine times cosine with the same angle measure becomes cosine squared 35. And then sine times sine, sine squared 35. And just like we saw on the problem right up here, when it's the same angle measure and it's sine squared and cosine squared and we're adding, it simplifies to be 1. And that does it. Okay, I'm going to pause the video here and I'm going to finish the rest of them later because my computer's dying and I didn't bring my charger. Cool. Okay, so we'll continue going over this. Oh, there's my hand again. So bye.